Hi, I'm Chuck Gallegos, co-chair of St. Luke's Environment Committee. I'm glad you could join us today for a tour of the St. Luke's Restoration of Nature. Many partners contributed to the funding of the project, and we couldn't have done it without them. The project cost approximately $1.5 million to design and install. The largest portion came from a grant by the Maryland Department of Natural Resources Trust, which is funded by a tax on rental cars. The project was designed and installed by the award-winning landscape architecture and ecosystem restoration firm Underwood & Associates. It began as the capstone project of Betsy Love in her training in the Anne Arundel Watershed Stewards Academy. It grew in scope and magnitude as funders and restoration professionals realized the potential of the site to showcase modern best management practices in an urban setting. Funds for the educational pathway that we'll be walking today came from a grant from the United Thank Offering of the Episcopal Church. The restoration treats storm runoff from 28 acres of urban development stretching across Bay Ridge Avenue. The design recognizes that treatment of storm runoff requires a complete balanced ecosystem consisting of native rocks, soils, plants, and microbial life. Not only was the hydrology reshaped, but native sandstone boulders and sand sediments were brought in, and invasive plants removed, and native trees, shrubs, and grasses were planted. The storm grading on Bay Ridge Avenue has a 42-inch pipe at a depth of 10 feet that ends in gravel further down the project. In a 100-year storm event, water will emerge from the grading and enter the project in a cog inlet that can be seen here. The basic philosophy of stormwater management is captured by the Watershed Stewards Academy slogan: slow it down, spread it out, soak it in. We try to capture as much water as we can, as high in the watershed as we can. The higher in the watershed that we can capture the water, the more time that natural processes have to purify it. Prior to construction, dye studies showed that water could travel from Bay Ridge Avenue to Back Creek in 10 minutes along the asphalt streets and concrete pipes. Now with the project installed, that time is 5 to 7 days. The project employs 5 different best management practices, or BMPs. The 2 that can be seen at this point are the bioretention or rain garden to the left of the path and a bioswale to the right. Rain gardens are built in natural depressions in the ground and are designed to hold water so that it infiltrates over a 48-hour period. It is planted with native plants that can withstand occasional inundation to help treat the water. A bioswale conveys water downstream to the regenerative stream channel, or RSC. The 42-inch pipe ends above the first step pool, where the water may be seen emerging from the ground in larger storms. The regenerative stream channel, or RSC, replicates the natural stream structure of pools and riffles created by the small rock dams called weirs. Weirs hold the water high in the watershed and allow infiltration to occur. It is intended that infiltration at the step pools will eventually saturate the aquifer so that the stream will run all year. This process, called rehydration, may take several years. There is more to treating the water than merely preventing erosion. Much of the cleansing of the water occurs underground. The step pools and the regenerative stream channel have been constructed in a way that promotes the microbial populations that transform a readily available form of nitrogen found in lawn fertilizers, which stimulates algae blooms, into a harmless form that we breathe all the time. To do this, the pools and channels were dug out to a depth of 15 feet and backfilled with sand, gravel, and wood chips. The coarse grains of the sand and gravel promote infiltration, and the wood chips supply the carbon for energy needed by the microbes to transform the nitrogen. This microbial process, which is called denitrification, returns nitrogen back to the atmosphere in a form that comprises 80% of the air we breathe and is non-polluting. The woodland at this site went unmaintained for many years prior to being restored. Many invasive vines grew up, forming an impenetrable green wall, making the area inaccessible. Workers had to hack their way into the woods using machetes to first gain access to the area. English ivy, Asian bittersweet, and Japanese honeysuckle are among the most persistent and problematic of the invaders. The standing dead trees near this sign are a testament to the detrimental effects of invasive species if left unchecked. Invasive vines will grow up the trunk of mature trees and eventually starve them of light. Besides killing trees, invasive plant species are generally unsuitable as food for wildlife, are shallow-rooted and thereby do not contribute to the infiltration of stormwater, and crowd out beneficial native plants. We call this bioswale coming off of Monroe Street Frog Alley because in the spring and summer that's exactly what it is. You should definitely try to make a visit here in the spring or summer to experience it. Stormwater captured off Monroe Street is treated by microbial action as it infiltrates through woody material and sand. Because of the porous sand and gravel underlying the bioswale, groundwater emerges on the downslope side of the path. The stormwater is transformed to clean water that seeps through rivulets on the way to the stream. In between, wetland plants find a home here, such as sedge, sphagnum moss, and pitcher plants. As we're walking down to the wetland, this is a good time to point out some of the native trees that we have planted. Sweet bay magnolias have been planted throughout the restoration. They prefer moist habitats and can withstand occasional inundation, so that you'll find them planted along the edges of the bioswales. They have very attractive creamy white blossoms that bloom June through August in this area. Another tree planted along the wetland is the Atlantic white cedar, which is actually not a cedar, but is in the cypress family. It was once common in wetlands and marshes of the Maryland coastal plain, but locally has become rare due to extensive logging and habitat loss. Its long, straight trunk was highly prized as sailing masts, and charcoal of the Atlantic white cedar was used to make gunpowder during the Revolutionary War. In the middle of the wetland areas, which are often in standing water, you'll notice bald cypress. These are among a small number of conifers that are deciduous, meaning their leaves change color and drop off in winter. This time of year, in late fall, they'll appear a golden brown, whereas they'll appear bright green in summer. When there is standing water in the wetlands, it may appear stagnant, but looks can be deceiving. Water in the wetlands is always moving, though the movement is nearly imperceptible. Sand, which is the predominant soil in the coastal plain, provides pathways for the movement of groundwater. Wetlands are very efficient at treating stormwater, so much so that we like to call them clean water factories. Wetlands remove carbon from the atmosphere. They can act like sponges in flooding situations and also trap sediment and runoff. They have a rich and robust microbial life found in the underlying sand and woody material. This microbial life makes wetlands the most efficient of bay restoration practices for nitrogen reduction. The excellent habitat provided here is home to dragonflies and their larvae, birds, tadpoles and frogs, fish, and turtles. Wetlands also provide sanctuary and nourishment for a wide variety of native plants, with root systems that help clean the water. As we approach the living shoreline near the bottom of the watershed, we notice that a permanent stream has been established, fed by water filtering out of the wetland. The sandstone cobble that has been restored to the stream keeps the water flowing swiftly at this point, so that it is well oxygenated when it enters Back Creek. Microscopic algae that grow on the surface of the stones, called periphyton, provide a food source for aquatic insect larvae and macroinvertebrates that are important in the food chain of a healthy stream. Living shorelines and tidal marshes provide essential habitat for fish, shellfish, and waterfowl. The native marsh grass, Spartina alterniflora, provides habitat for crabs, small fish, wading birds, snails, and other invertebrates. It's not at all unusual to see great blue herons feeding here. Green herons and terrapins have been spotted as well. Living shorelines contribute to climate change resiliency by trapping carbon, which is stored for long periods of time. They also provide a buffer against sea level rise. In a flood tide, water merely rises slowly up and recedes back into the creek. Living shorelines and marshes protect against shoreline erosion by absorbing wave energy from storms, boat wakes, and flood tides. If you look over to your right, you'll notice that the shoreline belonging to Severn House, which did not partner with us, is severely eroded and undercut by the action of waves. Tree roots have been exposed, and in time those trees will fall back into the creek. The shoreline to our left, belonging to Watergate Point Apartments, who did partner with us, initially looked like the one to our right. By installing the living shoreline, the low gradient of the shoreline was restored, and native grasses were planted that help absorb wave energy, and their roots help hold the soils in place. As we leave the living shoreline, we're going to retrace our steps back to the intersection in the path and take the branch to our right to return via the forest canopy. A healthy tree canopy is a vital part of the resort watershed. Together, trees provide life-giving oxygen through the process of photosynthesis and cooling shade for aquatic species in the bioswales and wetlands, or for any organisms seeking shelter on a hot summer day. Trees help control erosion by slowing the descent of raindrops and by roots that hold soil in place and aid in infiltration of the water. Trees provide water to the atmosphere through transpiration, and they provide food and habitat for insects and birds. Over 1,000 trees have been planted at this site. Every year, tons of carbon are being removed from the atmosphere and being stored in stems, trunks, and roots. In the climate of this region, trees benefit from having close neighbors to help protect from wind throw and drying out of the forest litter layer. The trees in a forest stand form a vast underground network through symbiotic relationships with fungi that connect the roots of neighboring trees. The fungi are more efficient than roots at absorbing nutrients and water from the soil, and the trees provide fungi with sugars that they cannot produce on their own. Stress signals for drought or insect attack may pass through these networks as well. We're back at Frog Alley now. I hope you've enjoyed today's tour. This tour today has been in late autumn when the leaves are down and the vegetation is dormant. That's a particularly good time to see the hydrology because the weirs and step pools and bioswales are visible. I hope you'll come back another time, spring or summer, and check out the really magnificent vegetation growing here. We have one more stop to make. That'll be at the pollinator garden. We're going to end here at the pollinator garden. I know it's not a lot to look at right now, but you should really come back and check it out when all the native shrubs and wildflowers are in full bloom. Insects, including honeybees, bumblebees, butterflies, and moths, are vital for the pollination of many cultivated and wild plants. They play a crucial role in the production of agricultural crops such as blueberries, raspberries, and tomatoes, as well as pollinating many wild flowering plants. Worldwide, pollinator diversity is declining, while the area of crops dependent on pollinators is increasing. Insect pollinators face growing pressure from the effects of intensified land use, including pesticide use, climate change, invasive species, and the spread of pests and diseases. Here at the St. Luke's Restoration of Nature, we have taken steps to make a welcome home for pollinators of all type. The garden is the design of master gardener and St. Luke's neighbor, Anne Brown. The plants in the pollinator garden have been chosen and arranged so that there is some attractive native flowering plant in bloom throughout the growing season from early spring to late fall.